Okay, this is version B of the quiz. All right, so first question, at a pressure of 97.4 kPa, this many moles of gas occupies the volume of this many liters. What's the temperature of the gas? All right, notice there is no language in the question that makes any reference to something changing. All right, you only see each unit being talked about once. All right, therefore that indicates the equation is going to be PV equals nRT. It says what is the temperature of the gas, so therefore that's what we need to get by itself. So we need to get T by itself. So we need to divide both sides by NR to get rid of NR from this side. That gives me this equation right there. Plug in the appropriate units. Notice that the value of R that we choose is the one that has kPa because the unit of pressure in the problem is kPa. All right. Solving for this gives us 165 Kelvin. All right, and the way that we know that it's Kelvin is because when you cross out all your units, Kelvin is the only unit that would be left. All right, follow-up question. What would happen to the final pressure if the final volume was halved? All right, so essentially we're just taking all the information from this problem and we're making one change to it. All right, and remember, if it doesn't mention changing a property, leave it, assume that it doesn't change. All right, so we should assume that based on this information here, the only things that are going to change are the volume, and that's going to cause a pressure to change. All right, we have an equation that involves volume and pressure changing while other things stay the same. It's P1 V1 equals P2 V2. All right, so what would the original volume be? That would be the original volume in the problem. All right. If we cut the volume in half, the new volume is going to be 15.2 liters. All right. The P1 is going to be the pressure that was indicated in the problem. All right. And P2 is what it's asking us to calculate. All right. So getting P2 by itself, we would get this, plugging in these values, gives us 195 kPa. All right. Notice that it's rounded to 3 sig figs because each one of these numbers going into the problem has 3 sig figs. All right. In this problem, when you see 154 liters, that's a volume. All right. It contains this many moles. That's an N. All right. Calculate the final volume. That word final indicates that there's a before and after. And we've got this as a final number of moles. All right. This is a direct relationship problem. We know that the number, as you increase the number of particles of the gas, the volume of the gas would increase, just like blowing air into a balloon. It gets bigger because there's more air. So we need to calculate the final volume. We need to get V2 by itself. So we can take this form of the equation and get rid of the fractions by cross multiplying. That would give us the top half right here. All right, we then need to get V2 by itself. So let's divide both sides by N1. The N1s then cancel from this side, giving us this equation right here. Plugging the information in from the equation gives us this. And the answer should be rounded to 3 sig figs because each of these terms has 3 sig figs. Okay, calculate the air with this volume, this pressure, and this temperature. What will be the volume of the balloon at STP? All right, remember, STP is just a way of telling a specific temperature, which is 273 Kelvin, and a specific pressure, which the pressure that you choose would be the one that matches the pressure that you already have. All right, notice we already have a pressure in kPa, so we're going to choose the value for standard pressure that matches that particular unit. All right, so that's why I chose this one right here. All right, it said what would be the volume. So we therefore have two volumes. We have the original volume and we have a later volume. The equation that has all those variables would be this one right here. To get rid of the fractions, we cross multiply to get the top half right here. All right, so if we want to get the new volume, which is V2 by itself, we need to divide by the other things on the side, giving us this final equation. Plugging in, we get we would have it like this. And one thing about sig figs, notice that the value that has the fewest number of sig figs would be this one right here. There's only 2 sig figs in that, therefore your answer should be rounded to 2 sig figs, which would be 280 liters. Okay, this is a partial pressure problem. Essentially, the total pressure is going to equal the sum of all the partial pressures. It's asking us what's the partial pressure of carbon dioxide, which is this one. So to get this by itself, we could rearrange this equation right here to give this right here. We could solve it, plug in the values that we have, and this is what would come out of your calculator. But notice that this is an addition-subtraction problem. Therefore, the sig fig would be determined by the measurement with the furthest left position of uncertainty. All right, in this number, it's the thousandths position. In this, it's the 10,000ths position. And in this one right here, it would be the thousandths position. So the thousandths position is the furthest left of those positions. Therefore, your answer should be rounded at the thousandths position. That's why the correct answer should have it rounded to 0.138 atmospheres. Okay, what pressure? So we've got a pressure, we've got moles, we've got volume, and we've got a temperature, which you should know by now needs to be converted to Kelvin. All right, there is no change mentioned in the problem. That means it's PV equals nRT. Solving for what we don't know, which is the pressure, gives this equation right here. Plugging in the values. Why do I choose this R value? Because it's the R value that's got millimeters of mercury, which matches the unit that the question asks you to solve for. Plugging things in, we would get this answer right here. And the last question, oops. Oops, sorry. The last question, what would happen to the final pressure if the temperature was tripled? Okay, so just take, here's one thing that you would be expected to know. If you're tripling the temperature, remember, what does temperature represent? It represents the amount of motion of the particles. And which form of temperature represents that? All right, that is going to be the Kelvin temperature. All right, so when they mean final, triple the temperature, they're saying tripling the amount of motion of the particles, which would be represented by by tripling the Kelvin temperature. All right, so pulling the information out of the problem here, we've got P1 over T1 equals P2 over T2. That is the equation that results from these things being changed while everything else stays the same. And we get P2 equals this expression right here. Plugging the values in here will give us this as your final answer.